Hi students, we will discuss level curves versus parameterized curves in the topic. So, we curve intuition. It could be a level curve, or it could be a parameterized curve, or it could be a polar curve, like that. So our question is, under what conditions we can express a level curve as a parameterized curve? Under what conditions we can express a parameterized curve as a level curve? So these are the questions we are going to address. Can we always represent a level curve as a parameterized curve? A parameterized curve is a level curve express. But under what conditions? Okay. So we will consider the first case. I will give a level curve. So how it will look like, that is interesting. So this is an example from textbook. Consider the set of all x comma y in R2 such that y square is equal to x minus x cube, or y is equal to plus or minus square root of x minus x cube. Okay, so let us try to parameterize this in the most evident way. So put x is equal to t, so y will be equal to plus or minus square root of t minus t cube, plus or minus square root of t minus t cube. So t comma plus or minus square root of t minus t cube will give us a parameterization. But what is the image of this parameterization, and in which interval t varies? These things need to be checked. So let us plot this curve. So plotting of curves requires some knowledge of calculus, but there are online tools available. I will show you the graph of this in Desmos. This is you can plot curves online in this website desmos.com. So if you type your equation here, y square is equal to x minus x cube, so this is going to be the curve. When x is greater than 1, x minus x cube is negative, y square is negative, that is not possible. So there is no part of curve lying for x greater than 1. Similarly, if x lies in between minus 1 and 0, again x minus x cube is going to be negative, that means y square is negative, impossible, so there is no curve lying in this part. And when x is less than minus 1, so this is going to be the behavior of the curve. And when x lying in between 0 and 1, this is going to be the behavior of this curve. Okay, so when you parameterize, you cannot write your t varying in a single interval. If I write t varies from, I want a single interval, namely alpha comma beta, but no single interval can give you a plot of this curve y square is equal to x minus x cube. So you cannot parameterize all level curves. This is a typical example. There is no single interval where t varies such that you can parameterize that curve in that interval. So if f satisfies some I will write as a theorem under what conditions you can express a level curve as a parameterized curve. So suppose f of x comma y is a smooth function of x and y is a smooth function of x and y that means all the partial derivatives of f exist and continuous. Of partial derivatives of all orders exist and continuous. And assume that at every point of the level curve C equal to set of all x comma y in R2 such that f of x comma y is equal to 0. So that is your level curve. We have del f. What is del f? It is called gradient of f. It is defined as the vector dou f by dou x, comma dou f by dou y. This vector is non-zero. So what is the meaning of that? Either this is non-zero or this is non-zero at every point. Then there exists a regular parameterized curve So let me remove this. I will add one more thing. So let P be a point on the curve. Let P x naught y naught be a point on the curve level curve C. That means at the point x naught y naught also del f is non-zero. Then there exists a regular parameterized curve. Then there exists a regular parameterized curve gamma of t equal to u of t v of t t in some interval alpha comma beta this interval contains 0, so 0 is in this interval such that the curve passes through t such that gamma of 0 is equal to p when time t equal to 0. The curve passes through p x0 y0 and the image of gamma is contained in C. Image of gamma is contained in C. That means you have a parameterization of part of C containing the point P. So a part of C you can parameterize. So this is what you have to prove. The proof will be discussed in the next video. Thank you.